Hassler here. I'm going to work through the 6.5 lesson. We're looking at exponent properties, something that you've seen before. It says, read through each of the following equations. Without showing any work or doing any calculations, decide if you think the equation is true or false. Then work the equations out to prove that you are correct. No calculator. You can change your true-false answer if necessary. If the statement is false, correct it to make it true in the last column. You may check your final work with a calculator. So again, this is going to be reviewing some exponent properties that you guys talked about last year. I'm going to go through each of these and then decide if they're true or false. That way you can see that worked out solution, why we're getting the answers that we're getting, and what we came up with in class. So in this first statement, I have 2 to the third times 2 squared equals 2 to the sixth. So I'm going to work that out. 2 to the third, that exponent says take that base, that's a base of 2, and multiply that out 3 times. 2 squared means, that exponent means multiply the 2 out twice. And it turns out that I have only 5 2's that are being multiplied, and so I can represent that as 2 to the fifth. So this statement turns out to be false. And one way we can correct that is saying 2 cubed times 2 squared should really be 2 to the fifth. Now, it's not the only way you can correct it. I had a few friends who decided to correct this statement. So they wrote 2 cubed times 2 cubed would work to get me 2 to the sixth. I thought that was pretty cool. In either case, we're changing the statement to make it a true statement. As is, it was a false statement. So now I have 2 to the fifth times 2 to the fourth equals 2 to the ninth. And again, 2 to the fifth means that I'm multiplying 2 out 5 times, then I need to multiply by 4 more 2's, and I have a total of 1, 2, 3, 4, 5, 6, 7, 8. I have 9 2's, and so yes, this is true. What people ended up remembering is that when I'm multiplying like bases, I can add the exponents. Those exponents tell me how many times the bases are being multiplied, and so I can add the exponents to have a total number of 2's, in this case, that would be multiplied. Let's take a look at the next one. It says 4 to the fifth divided by 4 squared equals 4 cubed. So again, I'm going to do this expansion. 4 to the fifth means that I'm multiplying 4 out 5 times. In the denominator, 4 squared means I'm going to multiply 4 out twice. And then because I'm dividing, I can say, well, hey, 4 divided by 4 is 1. And 4 divided by 4 is also 1. There's nothing else in the top and bottom that are in common to divide out. I'm left with 3 4's. Yeah, that's true. That does end up being 4 cubed. There are 4 3's left being multiplied together. So let's take a look at the next one. I have 5 to the fourth being divided by 5 to the sixth. Does that equal 1 over 5 squared? Well, again, I'm going to go ahead and expand this. So I have 4 5's that are being multiplied. I have, on the top, I have 6 5's that are being multiplied on the bottom. And again, I'm going to go through and do that division, right? 5 divided by 5 is 1. Divide again, divide again, divide again. And I have 5's left over, but this time they're in the bottom. So remember, when I did this division, 5 divided by 5 was 1. It's not that there's nothing left on top. It's that 1 is there, right? Everything divided to be 1. But I still have 2 5's on the bottom that are being, that are left over, being multiplied. And so, yeah, this turns out to be true. So the idea here is that when I divide like bases, I can subtract exponents, right? 5 minus 2 is 3. What's interesting in this problem is that when I subtract those exponents, I get 4 minus 6 is negative 2. That's the same as writing that I have 2 5's left over, but they happen to be in the bottom, okay? So I can still do that subtraction. All right, let's take a look at this next one. In this next one, it says 2 to the 0 equals 0. And if I were to type that in my calculator, it would be false. I would have an answer of 1. And in fact, several friends remembered that anything to the 0 power is 1. But I want to show you why that is. So let's start out by making ourselves a little table. We'll start with 2 cubed, and then 2 squared, and then 2 to the first, and 2 to the 0. It's a 0. Here we go. not a 6. There we go. All right, 2 cubed. Well, that means I have 2 times 2, that's 4, times another 2, which is 8. 2 squared, that's 4. 2 to the first, that's 2. So let's see how this pattern works. From 8 to 4, I have to divide by 2. 8 divided by 2 is 4. I could divide by 2 again. 4 divided by 2 is 2. Notice that my base is 2, so it works out that I'm dividing by 2. And if I continue my pattern, 2 divided by 2 is 1. So it turns out any base raised to the 0 power is 1. All right, let's take a look at the next set. In this next set, we have 4 cubed, then being raised to the 4th equals 4 to the 7th. Well, let's talk about whether that is true or not. So this right here, this exponent tells me how many times 4 cubed is going to be multiplied. So I'm going to write 4 cubed out. I'm going to write that out 4 times because that's what that says. It says take 4 cubed, what's inside the parentheses, and multiply it by itself 4 times. But this 4 cubed, this first 4 cubed means I really have 3 4s being multiplied. And this 4 cubed means I have 3 more 4s being multiplied. And this 4 cubed means I have 3 more 4s being multiplied. And this 4 cubed means I have 3 more 4s being multiplied. I have a total of 12 4s being multiplied. And so this one is false. And the property that people remember is that when I have an exponent, and then on the outside of parentheses, it's being raised to a second exponent, we multiply those exponents together. All right, this next one, I have 3/5 in parentheses raised to the 4th. Is that equal to 3 to the 4th over 5 to the 4th? Well, again, I'm going to expand this. 3/5 to the 4th means that I'm going to multiply 3/5 4 times. So it turns out that my 3 gets multiplied 4 times, so 3 to the 4th. And my 5 gets multiplied 4 times, so 5 to the 4th. Yeah, this turns out to be true. And one of the things my friend said in class today was, well, they're both in the parentheses. They both get the exponent. And I loved that. I loved that idea. They're both in the parentheses. They do both get that exponent. All right, here's another example similar to what we had up here. We said when we raise an exponent to a second exponent, you multiply. Yeah, 2 times 3 is 6. So that's true. All right, back to this idea of whatever's in the parenthesis gets the exponent. So again, 6 times 4 cubed means that I have 6 times 4, another 6 times 4, and another 6 times 4. It turns out that we have 1, 2, 3 6s being multiplied, and we have 1, 2, 3 4s being multiplied. And so this is true. But if we take a look at this next one, they look very similar. There's just one slight difference. And the slight difference is that the 6 is not in the parentheses. So that means the 6 does not get multiplied out 3 times. Only the 4 does. So I just have the 6 once, but the 4 is being cubed. That means that this part makes it false, and this would be the true answer. So in doing this at the boards, we had the opportunity to talk about exponent properties from last year. And so I'm going to scroll down to the next page and just review those exponent properties. And then your job is going to be to apply those exponent properties to the check your understanding problems. So anytime we have a base to the 0 power, we said that equals 1. Any base to the 0 power equals 1. When we have a to the m times a to the n, notice the a's mean that the bases are the same. We would add the exponents, a to the m plus n. So when you multiply, I'm going to say common bases, we're going to add exponents. In the next one, we are dividing common bases. Both bases are a. And when we divide common bases, we subtract the exponents. So again, I'm going to say when you divide common bases, we want to subtract exponents. This next one has A and B being divided, and they're both in parentheses, which means both of them get raised to that exponent. So both in parentheses means that both get exponents. I'm going to skip over to this last one because it's the same idea. Both the A and B are in parentheses being raised to the m, so that means that both get the exponent. And so it's the same idea. Since both are in the parentheses, that means both get the exponent. And so back to this middle one, you have a to the m with an exponent, and then you have that being raised to another exponent, and we say, well, then I'm going to multiply those exponents. And we say this is a power to another power. We are going to multiply exponents. So your job is to take those exponent properties that are a review from last year and complete this check your understanding problems. And if you have questions, let me know.